CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 7.
Page number 89, chapter number 7, Heat Transfer in Nature. On the right-hand side of this page, a QR code is given, on scanning to which you can get access to other resources related to the chapter. Pema and her brother, Palden, reside in Gangtok. On a cold winter evening, they are sitting around a fireplace. Palden shares his experiences of visiting Kerala during the winter vacation. He says that compared to Gangtok, winter in Kerala is comparatively warm and humid. Both Pema and Palden are curious about why some places are so cold and others quite hot. Hearing them express their curiosity, their grandfather, a retired science teacher, says Kerala is closer to the equator than Sikkim, and it also has a long coastline, which results in warmer and more humid weather conditions. Palden replies, "Yes, we learnt in grade 6 science and social science that for us on the earth the sun is the main source of heat and light. And around the equator, the climate is generally hot." As they are talking, Pema is keenly observing her grandmother cooking thukpa, a traditional Sikkimese dish, in a large metal pan. Pema asks, "Why are cooking utensils generally made of metals?" Palden immediately responds that they had studied in the chapter The World of Metals and Non-Metals that such materials are good conductors of heat. Children, at the bottom of this page, a picture is given where Pema and Palden are sitting with their grandparents. They are sitting outdoors near a campfire in cold hilly area. Behind them, a modern house is given with big glass windows, tall green trees and mountains. Their grandmother is cooking thukpa, a traditional Sikkimese dish, in a large metal pot placed over fire. Page number 90. On the top of this page, a dialog box with a picture of Palden is given. He asks, "How does heat get transferred in these materials?" Let us perform an activity to learn why certain materials are good conductors of heat. 7.1 Conduction of heat. Activity 7.1 Let us experiment. Children, let us hear a caution message before starting this activity. This activity should be carried out under the supervision of a teacher or an adult. Before the activity, let us discuss figure 7.1, which is given on the left-hand side of this page. Here, a long metal strip is held on a stand. 4 drawing pins are attached with the help of wax at equal distances. A candle flame is heating one end of the metal strip. Activity 7.1 Step 1. Take a strip of a metal such as aluminium or iron, about 15 cm long. Step 2. Attach 4 pins to the strip with the help of wax such that they are arranged at nearly equal distances, about 2 cm apart, as given in figure 7.1. Step 3. Secure the strip to a stand and label the pins as first, second, third and fourth, as given in figure 7.1. If a stand is not available, place the strip between 2 bricks for support. Step 4. Heat the end of the strip, that is, away from the stand, with a candle or a spirit lamp. Step 5. What will happen to the pins? Will they remain attached to the strip or will they fall? Predict the order in which the pins will fall from the strip. Record your observations in Table 7.1. Table 7.1 Falling of pins. This table is divided majorly into 2 columns. Column 1, pin falling first. Column 1 is further divided into 2 columns. First is prediction, second is observation. The second column of this table records Reasons for what you observed. Page number 91. You observed that the pin closet to the candle flame, pin first, falls first, followed by pins second, third and fourth. Why does pin first fall before pin second? Why did all the pins not fall together? From your observations, what can you infer? Do you think that heat is being transferred along the metal strip from the end that is being heated? As the heat travels along the strip and approaches a pin, the wax holding it melts and the pin falls. Here, the transfer of heat takes place from the hot end of the strip to the colder end. The process of heat transfer from the hotter part of an object to the colder part is called conduction. In this process, the particle that gets heated passes the heat on to its neighbor and so on. However, the particles themselves do not move from their positions. Materials like metals that allow heat to pass through them easily are called good conductors of heat. Because metals are good conductors of heat, we use utensils made of metals for cooking. In solids, heat transfer takes place mainly through the process of conduction. If we use a strip made of a material like wood or glass in place of a metal strip to perform activity 7.1, the pins will not fall. Can you think of the reason for this? Based on our learning from the chapter, The World of Metals and Non-Metals. Materials such as glass and wood do not allow heat to pass through them easily and they are poor conductors or insulators of heat. Clay and porcelain are also poor conductors of heat. That is why tea or coffee kept in such cups stays hot longer. Children, on the right-hand side of this page, a dialog box is given along with the picture of Pema. She is thinking that, now I know why we generally use metal utensils for cooking, whereas we prefer clay and porcelain cups for drinking tea or coffee. List some materials around you and classify them as good or poor conductors of heat in Table 7.2. Table 7.2, List of good or poor conductors of heat. This table is divided into 3 columns. Column 1 is serial number. Column 2, material. Column 3, good or poor conductor of heat. The second column of this table records some material like steel, wood, and for the third material, blank space is provided. In the third column, students may record whether the material is good or poor conductor of heat. 1 is done for you. Steel is good conductor. For other materials, blank spaces are provided for students to record their observations. Does your list include air? If it is there on the list, where have you placed it? You must have experienced that during winters we prefer wearing woolen cloths to keep ourselves warm. Page number 92. On the left-hand side of this page, a figure 7.2 is given. In this figure, a boy is sleeping on a bed with a blanket. Air trapped between 2 thin blankets act as an insulator is depicted from this figure. Woolen fabric traps air in its pores, and as air is a poor conductor of heat, it reduces heat flow from our bodies to our surroundings. As a result, we feel warm. Similarly, air trapped between the layers of clothing acts as a poor conductor of heat and keeps us warm. The presence of air between 2 thin blankets is the reason why we prefer them over one thick blanket to keep us warm. It is given in figure 7.2. Is it possible to construct houses that are not affected much by the outside heat and cold? Houses constructed in places with a very hot or cold climate often use the concept of heat transfer to keep them cool or warm. Children, let's go through an interesting box named as Fascinating Facts. It highlights fun facts, interesting observations, and curiosity-driven questions. This box reads, the upper regions of the Himalayas, such as the Mori block of Uttarkashi in Uttarakhand, experience an extremely cold climate and heavy snowfall during winters. Houses here are often built to stay warm during winters, with walls made of 2 wooden layers filled with cow dung and mud between them. As wood and mud are poor conductors of heat, they prevent heat loss and help in keeping the houses warm. There are houses with outer walls that are constructed using hollow bricks that keep them warm in winters and cool in the summers. This happens because the air that gets trapped in the hollow bricks is a poor conductor of heat. On the left-hand side of this section, a dialog box is given with a picture of Pema. Pema is asking, why is the smoke going up? Pema draws Paldane's attention to the rising smoke from the burning firewood around which they are sitting. 7.2 Convection. To understand why smoke rises, let us perform an activity. Activity 7.2. Let us investigate. Children, before doing this activity, let us discuss figure 7.3a, which is given on the left-hand side of this page. Figure 7.3a, initial setup, where 2 paper cups are hanging with strings from each end of a wooden stick. The stick is balanced horizontally. Coming back to the activity 7.2, Step 1. Take 2 identical paper cups. Step 2. Hang them using threads of equal length in an inverted position on the 2 ends of a wooden stick, as given in figure 7.3a. Page number 93. Let us discuss first figure 7.3 given on the right-hand side of this page. Figure 7.3b, hot air rising up. In this figure, one of the hanging cups is placed over a candle flame, so this cup has started rising. Step 3. Now, adjust the positions of the cups so that the stick is horizontal. Step 4. Place a burning candle below one of the cups, as given in figure 7.3b. Step 5. Observe what happens to the cup. Step 6. Record your observations in table 7.3 and think of probable reasons. Table 7.3. Recording observations and probable reasons. This table includes 2 columns. First column, observation about the cups. Second column, probable reasons for the observation. Children, blank spaces are provided in both of these columns so that you can record your observations. You observed that the cup under which the candle was placed rises up, which is given in figure 7.3b. Why is it so? The air around the candle flame heats up. As the air in the cup warms up, it expands and occupies more space. As a result, it becomes lighter and rises up. You can experience the expansion of air on heating it by placing a partially inflated balloon in the sun, which is given in figure 7.4. In figure 7.4, which is provided on the right-hand side of this page, an inflated balloon is placed in the sun. After the air in the balloon gets heated, it expands and the balloon becomes larger. You must have observed that when an incense stick, agarbatti, is burnt, smoke rises up. Smoke is a mixture of hot gases and tiny solid particles that are released when something burns. As it is warmer than the surrounding air, it rises up. Let us find out how heat transfer takes place in liquids by performing the following activity. Before starting this activity, there is a dialog box given on the right-hand side of this page. Here, Paldane is asking, how does heat transfer take place in liquids? Do liquids also rise up when heated like air? Activity 7.3. Let us find out. Caution message. This activity should be carried out under the supervision of a teacher or an adult. Step 1. Take a 500 ml beaker half filled with water as given in figure 7.5a. Step 2. With the help of a straw, place a grain of potassium permanganate at the center of the beaker's base as given in figure 7.5a. Step 3. Place a candle right below the center of the base of the beaker. Page number 94. Let us discuss two figures which are given on the left hand side of this page. Figure 7.5a, initial setup for demonstration of the activity. Here, a beaker is half filled with water. A grain of potassium permanganate sits at the center of the base of the beaker. Placed with a straw in the beaker, a candle is heating it from the below. Figure 7.5b, demonstration of convection in heated water is provided. The color of potassium permanganate moves upward from the center and come down from the sides. Coming to the step 4 of this activity, observe the movement of the colored streak in the water. Step 5. As you supply heat, a streak of color starts moving up and then coming down from the sides as given in figure 7.5b. Why does the streak of colored water go up in the middle and come down from the sides? The water at the bottom of the beaker gets heated up and becomes hot. It expands, becomes lighter and rises. The water on the sides of the beaker is comparatively cooler and heavier and comes down to take the place of the rising water. Then this water gets heated and in turn also rises. This cycle continues until the entire volume of water gets heated. In this case, the entire volume of water gets heated through the actual movement of water particles. This process of heat transfer is known as convection. It is because of convection that we see the movement of the colored streak inside the beaker. Thus, we can conclude that water, like air, gets heated up by the process of convection. Here, heat transfer takes place by the actual movement of particles of liquids and gases from one place to another. 7.2.1 Land and Sea Breeze. Paldane shares his experience of visiting a beach in Kerala during winter vacation and says, during the day, the sand or soil near the beach is hotter than the water in the sea. However, at night, the sand or soil is cooler than water. Pema replies, yes, different objects get heated and cooled differently. Let us check how land and water get heated and cooled by performing an activity. Activity 7.4. Let us investigate. Before starting this activity, let us explore figure 7.6, which is given on the left hand side of this page. Figure 7.6, measurement of the temperature of soil and water. Here, two balls, one with soil and one with water, each have a thermometer inserted into it through stands, are given. Question message. This activity should be carried out on a clear sunny day under the supervision of a teacher or an adult. Step 1. Take two identical balls as given in figure 7.6. Step 2. Fill one ball halfway with the soil and the other ball halfway with water. Step 3. Fix a laboratory thermometer in each ball as given in figure 7.6. Make sure that the bulbs of the thermometer are immersed in soil and water and do not touch the bottoms or the sides of the balls. Step 4. Place the setup in sunlight. Page number 95. Step number 5. Measure the temperature of soil and water every 5 minutes and record the data in table 7.4. Table 7.4. Temperature of soil and water when heated. This table includes 4 columns. Column 1, serial number 1, 2, 3, 4, 5. Column 2, time is given in minutes. In this column, 5 readings are provided in rows. Reading are 0, 5, 10, 15, 20. In column 3, temperature of soil can be recorded by the students in degrees Celsius. Blank spaces are provided. In column 4, temperature of water in degrees Celsius can be recorded by the students in the blank space which are provided. Study the rise in temperature of soil and water. Did the temperature rise by the same amount for both the soil and the water at the same time? If not, which one got heated faster? How much was the rise in temperature of the soil and the water in 20 minutes? After 20 minutes, you will find that the temperature of the soil rises more than that of the water. This indicates that the soil heats up faster than water. Does the soil also cool faster than water? After letting the soil and water get heated, bring the setup indoors and let it cool for 20 minutes. You will observe that the soil cools faster than water, just as it gets heated faster. People living in coastal areas experience an interesting phenomena caused by the heating and cooling of land and water at different rates. As the land gets heated faster than water during the day, it causes warm air above the land to rise. This causes cooler air to move from the sea towards the land. This movement of cooler air from the sea to the land is called sea breeze, as given in figure 7.7a. Children, let us discuss figure 7.7a first. Sea breeze. On the right hand side at the bottom of this page, figure 7.7a is given. In this figure, sea breeze on a beach during a sunny day is picturized here. Sea is on the left hand side and land area is on the right hand side. The picture is indicating air moves through arrows. Two houses on the warmer land and green palm trees along the coast, bending slightly, indicating the wind direction. Arrows are indicating that cooler air from above the sea moves towards the land. Warm air above the land moving towards the sea is indicated by the other arrow. Hence, in hot places, sea breeze relieves people from the heat. That is why windows of the houses in coastal areas are placed facing the sea. Page number 96. On the top of this page, figure 7.7b, land breeze is provided. Just like figure 7.7a, the same picture in the night time is provided, where two arrows are indicating the movement of breeze. First one is indicating the movement of cool land breeze from the cooler land to warmer sea, and the second arrow is indicating the movement of warm air from the sea to land. At night, the process reverses. In the absence of sunlight, land cools down faster than the water in the sea. As a result, the air above the sea is warmer and rises up. Cooler air from the land then moves towards the sea, creating a land breeze, which is given in figure 7.7b. Thus, people living near the seashore experience that the direction of wind reverses in the day and night. 7.3. Radiation. Do you remember when Pema and Paldane were sitting around the fireplace? They felt warm. There is a dialogue box in this section is provided with the picture of Pema. She is wondering and saying, "I wonder how heat from the fire reaches us." Their grandfather tells them that the heat transfer in this case takes place directly from the fire, hot object, to us by a process known as radiation. The heat of the sun reaches us through this process. Heat transfer by radiation does not require any medium. All objects radiate heat. You must have observed that a hot utensil kept away from the flame cools down after some time. What is the reason for it? The hot utensil cools down by radiating heat to its surroundings. Children, at the bottom of this page, an interesting box is provided. Dive Deeper box. This box contains advanced concepts that lead to questions for in-depth exploration of a topic. This box reads, why is it more comfortable to wear white or light colored clothes during summers and dark colored clothes during winters? Light colored clothes reflect most of the heat that falls on them, and therefore we feel more comfortable wearing them during summers. Dark surfaces, on the other hand, absorb more heat, and therefore we feel more comfortable with dark colored clothes during winters. Page number 97. There are many examples in our daily life where we can observe conduction, convection, and radiation happening together. Consider the case of water being heated up as given in figure 7.8. Let us discuss figure 7.8. Heating water in a pan. A metal pan is placed on a flame. Water is boiling into it. Let us identify the various ways in which the pan and the water get heated up, as well as the warmth we feel around the flame and the hot pan. Heat is transferred from the flame to the utensil by conduction. Subsequently, water in the utensil gets heated up by convection. The warmth that we feel around the flame and the hot utensil is due to radiation. Let us wrap up. From the activities, examples, and discussions so far, we find that there are three processes by which heat gets transferred. These are conduction, convection, and radiation. First, in conduction, heating takes place when one particle receives heat, transfers heat to the next particle in contact, and so on. The particles themselves do not move away from their positions. Second, in convection, heat transfer takes place by the actual movement of particles. Third, note that in conduction and convection, a medium must be present whose particles help in transfer of heat. 4. In the case of radiation, heat travels from one place to another and no material medium is required for its transfer. Children, one more interesting box named as Fascinating Facts is provided at the bottom of this page. Fascinating Facts box highlights fun facts, interesting observations, and curiosity-driven questions. This box reads, in the upper reaches of the Himalayan region, a traditional room heater, locally known as Bukhari, is used to keep rooms warm during winters. It consists of an iron stove in which wood or charcoal is burnt. A long pipe attached to the upper part of the heater serves as a chimney, venting out the smoke. Additionally, the Bukhari can be used for cooking as its flat top provides a platform for placing utensils. All the three processes of heat transfer are involved when this device is used for cooking and warming up the room. In this box, a picture of Bukhari is also provided, where a tea kettle is placed over the flame. Page number 98. You have learnt in the grade 6 science textbook Curiosity that the sun is the main source of heat for the earth. You have seen your parents drying wet clothes on the clothesline at home. Wet clothes dry faster on a sunny day, since the heat from the sun makes the evaporation of water faster. Thus, heat from the sun plays an important role in the evaporation of water, be it from clothes drying on a line or from water bodies like oceans and lakes. Let us look at the phenomena of water cycle to understand this in more detail. 7.4 Water cycle. You have also learnt in the grade 6 science textbook Curiosity that water exists in 3 states in nature. As a liquid, it fills the oceans, rivers, and lakes on the earth. As a solid, it forms snow, ice sheets, and glaciers in the mountains and the polar regions. As a gas, it exists in the form of water vapor in the Earth's atmosphere. During summers, some of the snow and ice gets converted to water due to the sun's radiation and flows down as rivers and ultimately into the oceans. The melted ice is replenished by fresh snow during winters. Water in the oceans, rivers and lakes gets heated due to the sun, and as a result, it evaporates as water vapor. Water also evaporates from trees and plants through transpiration. When water vapor rises up, it cools down and condenses to form clouds. Clouds bring rain, snow, and hail. This process is called precipitation. The continuous movement of water upward as water vapor and downward through precipitation, passing through soil, rocks, and plants, and finally returning to water bodies is called water cycle, which is given in figure 7.9. Let us discuss figure 7.9, which is provided in the middle of this page. Water cycle. In this figure, sun, clouds, ponds, mountains, rain, trees, with the arrows and some terms are given. These terms are related to water cycle. Water of ponds evaporates due to sun's heat and is called evaporation, which is mentioned in this figure. Water is also evaporating from trees, which is called transpiration. Vapors condenses to form clouds. Clouds brings rain through precipitation. Thus, the water cycle helps in redistributing and replenishing water in rivers, lakes, and oceans. It also serves to conserve the total amount of water on the earth. Rainwater that falls on the surface of earth flows into ponds, lakes, rivers, and oceans, or seeps into the ground. Page number 99. Children, on the top of this page, an interesting box named as Know a Scientist is given, where students can learn about the contributions of Indian and international scientists related to the relevant topic. This box reads, Brahmihir was an astronomer and mathematician of the 6th century CE in Ujjaini, modern-day Ujjain, Madhya Pradesh. In his work, Brihat Samhita, he gave methods of predicting seasonal rainfall. His predictions of seasonal rainfalls were based on factors such as cloud formation, wind patterns, position of stars and the moon, and other natural phenomena. You may have seen people drawing water from wells or hand pumps. This is the water that has seeped into the ground. On the right-hand side in this section, there is a dialog box with a picture of Pema is given. Pema is asking, how does water seep through the surface of the earth? Let us understand how water seeps through the surface of the earth by performing an activity. 7.4.1 Seepage of water beneath the earth. Activity 7.5 Let us investigate. Children, before starting this activity, let us discuss the figure 7.10. An activity to compare the flow of water through clay, sand, and gravel. In this figure, 3 inverted bottles, one with clay, one with sand, and one with gravel, have water dripping into the beakers below. Activity Step 1. Take 3 transparent used plastic bottles of 1 liter capacity. Step 2. Cut them in the middle and make a small hole in the cap of each bottle. 3. Keep them inverted and put some clay in one bottle, sand in the second, and gravel in the third, as given in figure 7.10. 4. Place 3 identical beakers below each bottle. 5. Add 200 ml of water to each bottle. 6. Predict the amount of water flowing out of each bottle. 7. Collect the water that flows through each bottle for 10 minutes. 8. Compare the amount of water that comes through each bottle. Table 7.5. Seepage of water. This table includes 3 columns. Column 1, bottles filled with. First, bottle 1, clay. Second, bottle 2, sand. Third, bottle 3, gravel. Column 2, prediction. Seepage of water very slow or fast. Column 3, observation. Seepage of water very slow or fast. Page number 100. On the left hand side of this page, 2 pictures are given in figure 7.11. Water readily moves and is stored where spaces are wide, open and connected. This figure illustrates how water moves through gravel and soil. Top part contains big round stones with large open spaces between them. Arrows indicate that water easily flows through these wide gaps. The bottom part depicts a mixture of gravel and soil, where spaces are much smaller and packed. Water moves slowly here. You may have observed that water seeps fastest through gravel, slower through sand, and slowest through clay. Why is it so? The spaces between gravel particles are wider when compared to those in sand and clay. Hence, water can seep through the gravel more easily. In this way, water seeps beneath the surface of the earth. This process of surface water seeping through soil and rocks is called infiltration. Water can infiltrate more readily if the spaces between soil and rock particles are wider, open and interconnected, as given in figure 7.11. The water that seeps through gets stored in the pore spaces of sediments and the opening in the rocks beneath the surface as groundwater. The underground layers of sediments and rocks that store water in pore spaces are called aquifers, as given in figure 7.12. This is the water we extract by digging wells or drilling bore wells in aquifers. This water may be a few meters to hundreds of meters below the ground, depending on the location. At the middle of this page, a picture is given in figure 7.12 aquifer. This figure represents how rainwater reaches underground and forms an aquifer. This figure is also illustrating trees, rain, house, well and aquifer. A well is illustrated here, reaching deep into the ground to collect this underground water. The layers of sediments and rocks storing water in spaces under the ground, that is aquifers, are majorly represented in this figure. However, groundwater is not unlimited. The growing water requirements of an increasing population have led to excessive groundwater extraction. Additionally, decreased vegetation cover and increased concrete surfaces in urban areas have limited water infiltration. As a result, groundwater is getting depleted. To address this, rainwater harvesting and recharge pits are used to replenish groundwater. Hence, the water cycle ensures that groundwater sources are recharged, thereby helping to ensure a sustainable groundwater supply. Page number 101. Since water scarcity makes life difficult, people have developed different ways to conserve water. For example, in Ladakh, people have developed innovative ways to conserve water by making ice stupas, which is given in figure 7.13 during the winters. Children, there is a box named as Science and Society which highlights the social connection and real-life applications. This box reads, Ice Stupa. During the spring season in Ladakh, streams often dry up, leading to scarcity of water, as the heat from the sun's radiation is not enough to melt the snow on the mountains. During winters, water from mountain streams is channeled down through underground pipes. This water is then sprayed into the cold air. As it falls, it freezes due to extremely low temperatures. The ice builds up layer by layer, creating a tall, cone-shaped structure called an ice stupa, which is given in figure 7.13. The ice stupa melts slowly during spring, providing water for farming and other needs throughout the summer. In this box, figure 7.13 ice stupa is also provided. Before coming to the next section, let me describe a small picture which is given at the right hand side of this page, where a cheerful girl is standing inside the opal walnut shell. She is holding a paper with some notes on it, and this picture is symbolizing the idea of summarizing the chapter. So, the name of next section is In a Nutshell. Point 1. There are three ways in which heat is transferred from one place to another: conduction, convection, and radiation. 2. The process of heat transfer from the hotter part of an object to a colder part is called conduction. In this process, particles do not move from their positions. 3. Materials that allow heat to pass through them easily are called good conductors of heat. 4. Materials that do not allow heat to pass through them easily are called poor conductors or insulators of heat. 5. In solids, heat is mainly transferred through the process of conduction. In liquids and gases, heat is transferred by the process of convection. Page number 102, point number 6. In convection, heat transfer takes place by the actual movement of particles. Land and sea breezes are examples of the process of convection. 7. Heat from the sun reaches the earth through radiation. 8. All objects exchange heat with their surroundings through the process of radiation. 9. Processes of conduction and convection require a medium for heat transfer, but no medium is required for the radiation process. 10. The principles of heat transfer are utilized in designing houses and clothing. 11. The continuous movement of water upward as water vapor and downward through precipitation, passing through soil, rocks and plants, and finally returning to water bodies is called water cycle. 12. The process of surface water seeping through soil and rocks is called infiltration. 13. Groundwater is the water that seeps through and gets stored in the pore spaces of sediments and the openings in rocks beneath the surface. 14. The underground layers of sediments and rocks that store water in pore spaces are called aquifers. Now coming to the next section, let us enhance our learning. Dear children, at the left-hand side of this page, there is an illustration where a boy is given encouraging us to participate in this section. The boy is sitting confidently on a block with a question mark. He is holding a word block named as inquiry. He is climbing through a rope and blocks. These blocks are shaped like a big stone and has a question word written on it. Words like why, what if, where, when, what could, how long, which, can it, whose, what will happen, what else, why not, what should are written. Children, this picture reminds us to keep asking questions to learn better. Now coming to the section, question number 1. Choose the correct option in each case. First, your father bought a saucepan made of two different materials, A and B, as given in figure 7.14. In this figure of saucepan, there are two parts of this. Part A, which is the metallic body, and part B, which is the handle of the saucepan. The materials A and B have the following properties. A. Both A and B are good conductors of heat. B. Both A and B are poor conductors of heat. C. A is a good conductor and B is a poor conductor of heat. D. A is a poor conductor and B is a good conductor of heat. Second, pins are stuck to a metal strip with wax and a burning candle is kept below the rod, as given in figure 7.15. Which of the following will happen? Before going forward, let us describe figure 7.15. Heat transfer setup is given at the left hand side of this question. In this figure, a long metal strip is held on a stand. 4 drawing pins are attached with the help of wax at equal distances. A candle flame is heating the middle of the strip. Point A. All the pins will fall almost at the same time. B. Pins 1 and 2 will fall earlier than pins 3rd and 4th. C. Pins 1 and 2 will fall later than pins 3 and 4. D. Pins 2 and 3 will fall almost at the same time. Page number 103. Third, a smoke detector is a device that detects smoke and sounds an alarm. Suppose you are fitting a smoke detector in your room. The most suitable place for this device will be A. Near the floor. B. In the middle of a wall. C. On the ceiling. D. Anywhere in the room. Before coming to the next question, children, let us discuss an illustration given on the right hand side of this page. In this image, a smiling girl is climbing up step by step through a rope ladder. Each step of a ladder represents words like curiosity, exploration, inquiry, discovery, innovation. The picture is indicating that these steps lead to innovation. Question number 2. A shopkeeper serves you cold lassi in a tumbler. By chance, the tumbler had a small leak. You are given another tumbler by the shopkeeper to put the leaky tumbler in it. Will this arrangement help to keep the lassi cold for a longer time? Explain. Question number 3. State the reason or reasons whether the following statements are true or false. First, heat transfer takes place in solids through convection. Blank space is given to write your answer. Second, heat transfer through convection takes place by the actual movement of particles. Blank space is provided. Third, areas with clay materials allow more seepage of water than those with sandy materials. Blank space is provided to write your answer. Fourth, the movement of cooler air from land to sea is called land breeze. Blank space is provided to write your answer. Question number 4. Some ice cubes placed in a dish melt into water after some time. Where do the ice cubes get heat for this transformation? Question number 5. A burning incense stick is fixed, pointing downwards. In which direction would the smoke for the incense stick move? Show the movement of smoke with a diagram. Question number 6. 2 test tubes with water are heated by a candle flame as given in figure 7.16. Which thermometers, figure 7.16a or figure 7.16b, will record a higher temperature? Explain. Let us discuss more about figure 7.16a and figure 7.16b. 2 thermometers dipped in 2 test tubes filled with water are given here. In figure A, burning candle is placed at the bottom of the test tube. In figure B, burning candle is placed near the top of the test tube. Page number 104. Question number 7. Why are hollow bricks used to construct the outer walls of houses in hot regions? Question number 8. Explain how large water bodies prevent extreme temperature in areas around them. Question number 9. Explain how water seeps through the surface of the earth and gets stored as groundwater. 10. The water cycle helps in the redistribution and replenishment of water on the earth. Justify the statement. Children, on the left-hand side of this page, an interdisciplinary zigzag rope chart is provided, which is depicting that all the areas like history, art, geography, society, technology and economy are integrated. Let's move to the next section and do some integrated projects in this section. Exploratory projects. First, society. Visit a site of water harvesting or a recharge pit. Find out from people how they are constructed and how they work. Prepare a report with illustrations. Second, activity. Tightly wrap a thin paper strip around a metallic rod. Try to burn the paper with a candle while rotating the rod continuously. Does the paper burn? Explain your observations. Third, activity. Take a sheet of paper, draw a spiral on it as given in figure 7.17a. Cut the paper along the spiral. Suspend the paper as given in figure 7.17b above a burning candle. Observe what happens. Provide an explanation for your observation. Figure 7.17a, a cutting paper in spiral is given. Figure 7.17b, spiral paper above a burning candle is given. This chapter ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 7. Narration Harsh Priya. Sound recordist Virendra Rawat. Production assistant Amarjeet Sarkar. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.